All right, gang, welcome aboard. And here we go with chapter 3, forward building quadratic models. So that's our goals for today. And we're also going to look at some of the data there on example 3. So here we go, build quadratic models from verbal descriptions. It says here in economics, revenue R is in dollars and is defined as the amount of money received from the sale of an item that is equal to the unit selling price P in dollars of an item times the number X units sold. So revenue is equal to X, the items, times price. So that makes sense. If I take, 20 items times $100, that's going to give me my total revenue. Okay. Law of demand states that P and X are related. So as one increases, the other decreases. The equation that relates P and X is called the demand equation. When the demand equation is linear, the revenue model is a quadratic function. And that's what we're trying to build today. We're trying to build a quadratic. So taking a look at example 1, we're going to use that information. It says maximizing revenue. Marketing department at Texas Instrument has found that when a certain calculators are sold at a price P dollars per unit, the number of calculators, that's X, is sold is given by this demand equation. X equals 21,000 minus 150P. Okay. So part A, they're going to ask us to find a model that expresses R, revenue, as a function of P. Well, we already know R is X times P, and what they want us to do is get it only in terms of P. So again, the idea is we want to get this X out of here. The good thing is they gave us what X was right there. We can pluggy-chuggy that in. Okay, so if I'm trying to answer part A, I'm going to plug in that 21,000 minus 150P, and then multiply that by P. And if I want that simplified, I'm going to go ahead and distribute. So in terms of function notation, revenue, in terms of price, I'm going to get, if I multiply and put it in descending order, I've got P times negative 150. P is negative 150 P squared. And P times 21,000 is a positive 21,000 P. Okay, so that's part A. That's, again, my revenue in terms of P. All right, so what is the domain of R? So let's go ahead and take a look at this graph. So I grabbed my calculator. Now I've typed in the function. I've got, again, negative 150P squared plus 21,000P. And what we want to do is we want to see what X values are we looking at for revenue, okay? Now, again, this is a quadratic, and we should know this is a frowny face because it's a negative. So we're going to take a look at what this graph looks like. I always start in either changing my window, messing with those numbers, or you can always try your zooms. I always use zoom 6. I'm not going to see what I want. Those are bigger numbers. And I try zoom 0, that's zoom fit. And again, we should see a frowny face here, and this almost looks linear. The idea is this thing's zoomed in too much, so I'm going to try to zoom out. Zoom 3 and then press enter, and it zooms out. And it's starting to curve a little bit. I'll press enter one more time, then that zooms out one more time. Okay. So again, a rough sketch of what this looks like domain-wise. I see that it goes up and comes down. Now, the only domain that I care about, the only X values I care about is where my revenue is above that X-axis. So I want to know from here to here, what is my graph? I want to know what this hump is. Okay, so I go to Y2, plug in 0, and I graph that line going across. I can find the intersections. Second trace, intersect, first curve enter, second curve enter, guess. That's 0, 0 there. That makes sense. Again, if my price is 0, my revenue is going to be 0. And then I'm going to go over here and find that other one, second trace, intersect, first curve enter, second curve enter, guess. I'll move my cursor over towards the other intersection, press enter, and it jumps to the nearest intersection. That one is 140, 0. Okay. So domain, if you're looking at it as a set, your domain low number, again high number is 140. P is in the middle, and then less than signs. If you want to talk about 0 revenue, we can put equal to as well. Okay, so again, P is in the middle. If you want to do interval notation, which I prefer, I'm just going to go low number to high number is what I see, 0 to 140. Okay. So I take a look at the next question. Next question says, at what unit price should be used to maximize the revenue? Again, we're trying to find the max, and that's going to be on the top of our mountain. Okay. So I'm going to go ahead and find the top of that mountain using the calc real quick. So I'm going to go second trace, maximum. Left bound, get to the left. Press enter. Right bound, get to the right where it's decreasing from left to right. Press enter. Guess, press enter. And I got 69.99999. You might have got 70.0000001. We want to go ahead and round that. So that's a 70, comma, and 735,000. Okay. Now remember what these represent. This represents P, my X value, and then this one represents my Y or my R value. So to answer the question, what unit price should be used, my X value, or in our case, our P value, was 70 bucks. If this price is charged, what's the maximum revenue? Again, that's R. So R of 70. That's, again, function notation like f of x. R of 70. When my price is 70, I get a maximum revenue of 735,000 ducks. No, bucks. Okay, so that's our values there. Last but not least, it says how many units are sold at this price. Remember, units is our X values, how many calculators are being sold. And you have a couple options. You know P is 70. You can plug it in here and figure out that number. Or, if you remember, we have this formula, R equals XP. If I divide both sides by P, I will get X equals my revenue divided by my price. So if I take 735,000 and I divide by 70, I will get how many units I should sell. Okay, so if I take that in my home screen, 735,000 divide by 70, and I get 10,500, and we're doing calculators. Okay. Last question I have here is, what price should Texas Instrument change to collect at least 675,000 in revenue? Okay, so we want to lease that. Okay, well, that is not my P value, my X value. That's my R value. So R is 675,000. That's again our Y value. So think of this as Y2. And this is really a great question for tomorrow. We want to know where that graph is about 675,000. Okay, so what's the price? What's P? Question mark. Well, let's find out. Let's use our calculator. So instead of Y2 is 0, I'm going to make Y2 $675,000. I'm going to go ahead and graph that. I should see a horizontal line going across. And visually what I see kind of looks like this. Going across is Y2 is 675,000. And I want to find that intersection. I want to find that one. I can kind of tell that there's two intersections here. So I want to find both of those intersections. So I'm going to go second trace, intersect. First curve enter, second curve enter, guess. The first one I found was at 50. So that's a $50 price. And the other one, let's see, second trace, intersect, first curve enter, second curve enter, guess. This is where I move my cursor towards the one I want to find and press enter. And that one's at 90. Okay, so what prices do I need what prices should Texas Instrument charge to collect at least? I need to charge low number, high number, prices in the middle, and then less than signs. At least is equal to as well. So I need to charge 50 to 90 bucks for these things to earn at least 675. Okay. So if you want to write that as a interval notation, It's low to high, somewhere between 50 and 90 bucks. Okay. Da-da-ding, ding, 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 ding. You are a farmer. And right now we have Beth as a farmer. She has 3,000 feet of fencing available for question number 2. And we want to enclose this rectangular field. Okay. And part A says express the area of the rectangle as a function of x, where x is the length of a rectangle. So again, here's my length, here's my width. And I'm going to mark these with x's. And then I don't know what these are, but I know they're different. So I'm going to call these y's. Okay. And now they want us to express the area of this guy in terms of x. Well, right now I can do that in terms of 2 variables, x and y. Okay. So there's my area, but now the problem is this is in terms of y, so I need to have some other information to get rid of that y, kind of like what we did with that other one. Okay. Now they don't blatantly tell you what the equation is, like in example 1, but we have to come up with it with this one. And that's where this information comes back. Beth has 3,000 feet of fencing available to enclose this rectangle. Okay. Well, we're talking about what here when we talk around the distance around? And y'all would say perimeter. Perimeter is just adding up all the sides. So we know 2x plus 2y is our perimeter. And Beth, that gal, she's got 3,000 feet. Okay. Well, I want to get rid of this y. So I'm going to go ahead and solve for y. So I'm going to go ahead and subtract the 2x over. So I've got negative 2x plus 3,000 equals 2y. And now I'm going to divide everything by 2. And I'll write over here what I got. I got y equals negative x plus 1,500. That's what my y is. Now I can plug it in, plug that in. That's area in terms of x. And now I have x times this quantity of negative x plus 1,500. Okay. From there, we can go ahead and simplify. And now you can see where this comes in with quadratics. I get negative x squared plus 1,500x. Okay. Again, graphically, we should know that this is a nice, pretty parabola. So we're going to go ahead and graph this thing. Okay. Something like this. And we're going to ask us to answer the next question. This is for what value of x is the area the largest? Again, we got a frowny face because that's a negative, and now we can find this maximum. So let's take a second. Let's plug it in our calc and see what we get. So I have this stuff in there. I'm going to go ahead and delete it out. I've got negative x squared plus 1,500x. Okay, I'm going to go ahead and zoom 6, knowing I'm not going to see what I want. You can, again, mess around with your window, or let's try zoom out. Zoom 0. Okay, now that looks like a line. That doesn't look like what we want. The idea is it's zoomed in so much, I got to zoom out. So zoom 3. Zoom 3 again, just press enter, press enter, press enter, and there we go. There's the top of the mountain. So I zoomed out probably about 5 times. So I'm going to go ahead and find that max. Again, second trace, maximum. Left bound, get to left. Right bound, get to the right. Press enter, and there we go. Again, go ahead and round that value. I've got 750, comma, 562,500 for y. Okay, now remember what this represents. This represents x, the length of my rectangle, and that's my area for y, a and y. Okay, so to answer the question for what value of x is the area the largest, that's 750 feet. What is that maximum value? Okay, so where's the area of the max? That's 562,500, and that is feet squared. And your answer is that question. All right, so for the last question for today, this is looking at goal number 2, where we're building quadratic models from data. Example 3 is talking about, we got a height of a ball, and we got this shot putter, and he throws a ball in an inclination of 45 degrees to the horizontal. Following data represents the height of the ball, h in feet, and at that instant that has traveled x feet horizontally. So again, big idea. Guys shot putting this thing, and it's going in a parabola. Okay? So it's going to again look like a parabola most likely. So they give us some data, the distance x horizontally to the height. Okay? Okay, so this is our distance horizontally. Okay, and this is our height. And what we want to do is use a graphing utility to draw that scatter diagram. So I'm going to go ahead and plug those in. I'm going to do it real quick though. You guys can pause me if you need, but I'm going to go stat edit, and I've already put them in for us. So I have list 1 and then list 2. I have all those guys in. Then I'm going to go to my y equals, and I'm going to turn my plots on. If I have anything in here, I'm going to turn them off, and now I'm going to graph it. And there's my parabola. Quiz or test, I would want a little rough sketch of what you see. Doesn't have to be perfect. It gives you an idea of what we got. Okay? Says in part B, use the graphing utility to find the quadratic function of best fit. This no longer looks like a line. This looks like a quadratic. It goes up and then comes back down. So we're going to go and do the exact same thing. We go stat. We'll go to calc. And now instead of number 4, we want number 5. So again, stat, calc, number 5, quadratic regression. We want list 1, list 2, and now we want to store reg EQ in alpha y equals, or alpha trace, number 1. And then we calculate. So again, alpha trace is where we find that y1, and it calculates our a, b, and c value. Okay, a is the number in front of x squared, b is the number in front of x, and c is our constant. Okay, so now I've got my nice pretty function. I'm going to do h of x here. And now I've got negative 0.0037 x squared. I've got plus 1.0318 x, and then I got plus 5.6667. Okay. Now again, when I go to y equals, that's stored in. If you don't have that option to calculate, reminder where that's at, you go to vars. Vars is right next to clear. You go down to statistics, EQ, and then reg EQ, and it copies and pastes that whole thing. Now you can see that thing fits that data pretty stinking well, right? Now this allows me to answer any question that they have. Okay. So in part C, it says use the function found in part B to determine how far the ball will travel before it reaches the maximum height. So we want to find where this x value is here. We can do that pretty easily. Second trace maximum. Left bound gets a left where it's increasing. Right bound gets to the right where it's decreasing. Guess, press enter. And there we go. We get maximum right there at 138.98, comma 77.38. It didn't say what to round to. Remember, this is x, this is h. So x is 138.98 feet. That's where it maxes out. Okay. And part D says use the function found in part B to find the maximum height, and that's our h value. So h was 77.38 feet. Okay. So ladies and gentlemen, give my math lab a try. Actually, I have a worksheet for you. Give that worksheet a try, and you guys should do great. Okay, and I'll be back the next day to take questions. Guys, have a great day. See ya.